My name is Philippe, and this is Andrés. We are the Cross Product. Andrés is a co-founder of the Cross Product, and he has a PhD in point cloud processing. So before we start telling you what we do, let's give some numbers. We have 40 million of kilometers of road worldwide. That's a lot of kilometers. And most importantly, those 40 million kilometers will occur 500 million deaths and injuries on the roads worldwide by the year 2030. So here we are going to tell you what we do and maybe answer this question, how can we help reducing this number? So at the Cross Product, we deal with 3D point clouds. I guess if you are here at Intergeo, you probably know what is a 3D point cloud. When you look at this picture, you see something. It's a highway, okay, simple. If we want to process this, this has no meaning at all. It's just a list of points. Of course, when we see it as humans, we see it's a highway, we see the road marks, we see the safety barriers, the bridge, but the file doesn't know anything about this. So what we do at the Cross Product, we extract features from this point cloud, meaningful features. What we start doing is classifying. So basically, we will assign a class to every point, whether it's a safety barrier, concrete or metal, the road, the markings, bridges, vegetation. We put every point into a class. It's a very important step because then you can focus on specific things. The second thing we do is we vectorize this. So we create polylines out of the road marking and out of the safety barriers. One thing important, automated. This is fully automated. You give us the point cloud, we deliver the polylines. With those polylines, you get the full geometry in 3D of the road. And we can, with this, reverse engineering the highway. So calculated the curvatures, the slopes. So you give us a point cloud and you have the model of your highway, the geometry of your highway. We do the same for railway. Classification, we classify the rail. We have a class for the rails, the ground, vegetation, the poles, and the wire. And again, with this, we can vectorize. So we'll vectorize the rails, so you get the geometry of your track, fully automated. And then we have business applications. When we have done this, we can virtually circulate train on the track and verify if it clashes with platforms, bridges, other train vegetation. So that's called clash detection. The question was how we can save lives with point clouds. Before we answer the question, I will introduce a partner. This partner is iRAP. So iRAP stands for International Road Assessment Program. It's a program from a charity in UK that is sponsored by the United Nations. And the goal is to save 2 million people from death or injury by year 2030. How they want to do it is they have defined a framework how to assess a road and how safe it is. And then they will advise what should be invested, what money should be invested into the road to make it safer. They have a lot of statistical data, so they can correlate that if the tree on the side of the road, if it's less than 1 meter, and if the diameter of the tree is more than 10 centimeters, that's a high danger. So the good thing with this is that they have defined a very detailed framework how to assess road safety. For example, they need to extract number of lanes and the direction of the lanes, the width of the lane, the radius of curvature. Those are features that needs to be extracted from the road. And also what's on the side here on the road. 1 meter, 5 meters, even 10 meters on the side of the road. They want to know what's there. So we have estimated that it takes 2 million man working days. So it's one person working for 2 million days. 2 million days is about the time when the wheel was invented. So one person working since the wheel was invented to assess all those roads. So now if we combine this specification and our algorithms, something is coming up. What's missing? Data. Where is the data coming from? So fortunately, guys like TomTom are running all the roads worldwide on a regular basis to update their own algorithms. And this data is now available for anyone. They're starting to sell these data. So now if we combine TomTom data, iRAP specification, and the cross-product our algorithms, by reverse engineering the highways, We can, for example, detect the number of lanes and the directions, which is one iRAP feature, the width of the lanes, which is another iRAP feature, and the curvature, and much more. And now, if we use our clash detection algorithm that I showed you on railway, we use it on roads. We have the lane, we can have a gauge, and circulate the gauge on the road virtually, and that identify all the clashes. Here we have a clash with a pole. Here we have clash with vegetation, buildings, etc. And we become compliant with what needs to be done manually to detect what's on the side of the roads. We believe that with this approach, we can reduce the assessment time by 100, which is quite a lot. That's the end of my presentation. We have a full audience. Thank you for listening. So if you have questions, I'll be happy to take them.